Your notes about the light bulb itself. This is your basic light bulb. This metal part down here is the electrode. That's where it goes into contact with the socket. Then there's a very thin wire that goes up into the light bulb, and the electrons travel along this wire. They move and vibrate when they're excited by electrical energy. And a light bulb actually converts electrical energy to light energy. Okay, so we'll look how this happens. So the electrons become excited, and they transfer their energy through a process called conduction, which is like pool. When you hit the cue ball, it moves and it hits the next ball, and that next ball moves, but the cue ball stops. And it's like this, where you have, if I put this much energy into this set of balls, this much energy is going to come out. It's going to travel through them and move the ball. So watch this. If I put a lot of energy, if I put just the tiniest bit of energy. So it's the same way with conduction. So these electrons are moving along this filament, and they're colliding with the electrons in the gas that's in the light bulb. And that causes the electrons in the light bulb to become excited as well. And you know, when electrons get excited, they move away from ground state. Then they have to return to ground state. They release energy. So the thing is, when we pick out a kind of metal to be the metal inside the light bulb, we have to pick, and it's very thin, it's a filament, and a filament is just like a thread, like a fishing line is a filament. The strings of a spider web are like filaments, very fine. So since we're going to have this metal be so fine and fragile, it has to be a metal that's not going to melt easily, because you probably know electricity can be hot. So we have to pick a metal that's got a very high melting point. And if you remember, melting point is a physical property. It doesn't say that it's reacting or not. So it's not chemical, it's physical. And the element they've picked is tungsten. And the symbol for tungsten is W, because it used to be called wolfram. So tungsten is the metal that's chosen to be in the filament of the light bulb. Now for a gas, we have to have a gas that's not going to react. It's not going to blow up. Oxygen would be a bad gas to put in the light bulb because it would react and blow up. So they've got to have a gas that's very stable and unreactive. And to say something is unreactive is to describe a chemical property. Remember, chemical properties are, does it react or does it not react? So the gas they've chosen is argon. And argon is a noble gas, and it's in family 18. And all the gases in family 18 are stable like this. They don't react. And we'll talk about why later. Okay, so I'm going to take my light bulb and put it in the microwave. You shouldn't do this at home unless you know, your parents are there. But if you do it, you have to put oil or water into the cup. Baby oil will work. I'm just using cooking oil. Into the cup, and don't use styrofoam. Styrofoam, it's foam. It's like whipped cream. It's not going to last in the microwave. It's going to melt. So you have to make sure that your electrode is totally immersed in the oil. I'm going to put a little more in here. Don't put the light bulb in the microwave. That doesn't work. Alright, so my electrode is totally immersed in the oil. Now, I'm not using electrical energy to excite these electrons. I'm using microwave energy. So we'll see what happens. Now, if you see colors, they're going to indicate the amount of energy those electrons had to absorb to pull away from the nucleus. So that tells us how close the electrons are to the nucleus when they're in ground state. So if you do this at home, immerse the metal part in oil or water, and then just do it for anywhere from 8 to 12 seconds. If you have a real high-powered microwave, you might want to just do it for 5. I've melted and blown up stuff and broken stuff, so you could have a mess. Don't think it's always going to just be easy. So here we go. So you see we've got, I did it for too long. Blue. Okay, let's let it cool off for a second. bulbs burned up. But anyway, that's what we did in class today. We learned about how we can use the light. So when you saw the blue light come from the light bulb, that told you that that electron had a lot of energy, had to absorb a lot of energy to pull away from the nucleus. So it was close to the nucleus. And we can measure the exact amount of energy that is with our technology today. The orange and green light, and the red light, which you didn't see red light, but the green and orange light, you know, those electrons were more loosely held by the nucleus and didn't have to pull away so far. And we'll learn more about the structure of atoms and where the electrons are located around the nucleus later this week. Thank you.